Hey guys, welcome to question FM335 of the Further Maths Fortify study guide. This question reads, Town A and Town B are in the same time zone. Dan lives in Town A, which has a location of 0 degrees north or south, 80 degrees west, and Brittany's dojo where he trains karate is in Town B, also 0 degrees, 93 degrees west. On one day in December, the sun will rise in Town A at 5:54 a.m. Question FM335 then asks us, assuming that 15 degrees of longitude equates to a 1 hour time difference, the time that the sun is expected to rise in Town B is what? So, we're going to have to figure out a couple of things here. First of all, how far apart the sun, what the time difference is in terms of the sun rising in these different towns. Not to be confused with the local times. A lot of people might think that because they're in the same time zone, the sun rises at the same time. But just because two towns are within the same time zone doesn't necessarily mean that the sun is going to rise at the same time. In fact, if one is more further west, that sunrise is going to happen later for them. So we'll explore that a little bit. So we're going to figure out the time difference, and then we're also going to have to figure out which town the sun rises in first and which one it rises in second. So the first little formula that we can use is going to be this, so the degree difference, so the difference in the locations of these towns when it comes to their east and west location over 15 will give us the portion of an hour that we need. So for example, if we had degree difference of 10, then this would be 10 over 15, which would tell us that it would take 40 minutes. And the way we convert it into minutes is by taking that 10 over 15 and timesing it by the 60 minutes that would make a full hour. So if we have 15 over 15, we'll have 60 minutes. If we have 10 over 15, we'll have 40 minutes. If we have 5 over 15, we'd have 20 minutes, so on and so forth. So this is going to equal how many minutes apart these two towns are. So if we delve into this a little bit, the degree difference, I'm just going to abbreviate it as DD for now. So one of them is at 93 degrees west. In fact, Town B is 93 degrees west. Town A is at 80 degrees west. So the difference is going to be 13 degrees. Substituting this degree difference into our little formula up here, we get 13 over 15 times 60. Plugging that into a calculator, we should get 52 minutes. So we know that these two towns are 52 minutes apart from one another. The next thing to get clear on is actually how this is going to work. So we've got Town A at 0 degrees 80 degrees west, and we've got Town B at 0 degrees 93 degrees west. So one of the next things we want to figure out is how this works. Now, a nice little way of remembering how this works, you might want to have this somewhere in your notes, is that the order of the sun rising when it comes to planet Earth is the further we are east, so the higher east locations will come first. They're the first ones to experience the sunrise on a given day, which goes down to the low east locations, which then goes to the low west locations, and finally the high west. So have a play with a globe if you can get your hands on one, or go back to your your textbooks and have a look at this. But this is the order that each day will flow in. So the highest east locations will come first, down to low east, then low west, then high west. So in this scenario, since Town A is lower west than Town B, probably shouldn't have made that so long. We know that Town A is going to have their sunrise before Town B does. So Town A has their sunrise at 5:54 a.m. and then adding 52 minutes to this. So town B is going to have their sunrise 52 minutes later, which transferring that across becomes 6:46 a.m. Meaning that our answer to the question, what time is the sun expected to rise in town B? Option D, 6:46 a.m. If you guys have any questions about this question, please drop them in the comments below. Otherwise, I will see you in the next video.